This is the last video for March 10th, and we're going to see how we can graph a slant asymptote. Here we know we're going to have a slant asymptote because the degree in the numerator is bigger than that of the denominator. We just need to figure out where that slant asymptote is happening. Here we cannot factor this. We can't factor this, so that's going to stay as is. And we know that x can't equal -1 because this doesn't factor. We know we have a vertical asymptote at x equals -1. Let me pause there. I just want to re-clarify. Up here, this graph, please ignore this. Plug in three values. H of 0, -1. H of 0.5, which is this value here, would give us like -2.67, something close to that. And then h of -0.5 would give us 0. So our function behaves like this. Outside, we only need 1 point. On the outside, we know what's happening. On the inside, if we're ever in between two asymptotes, 3 points. Because what can happen is it could have this shape, it could have this shape, or that shape. Here we plotted 3 points, so we know it's going to behave this way. I just want to clarify that because I feel like I was sloppy on the last video. Now, back here. Slant asymptote because the degree is bigger in the numerator than it is in the denominator. So we can do some long division. What we're dividing by, we're dividing x plus 1. We're dividing by x plus 1. So our little corner here would be -1, and we're dividing this by x plus 1. So our coefficients will be 1, -3, and -2. So we can drop down this 1 times -1, add these two to get -4, 5, and get 3. And so what this is telling us is that we have 1x, or just x, minus 4. Because our degree was 2, when we do the division, our degree is going to be 1, x minus 4, plus, since our remainder is positive, 3 over x plus 1. And whatever came out even, this piece here tells us our slant asymptote. So we know this function has a slant asymptote at y equals x minus 4. So now let's graph this function. So if we graph this function, I'm going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Vertical asymptote, we know that x equals -1. Slant asymptote. Our slant asymptote is at y equals x minus 4. How the heck can we graph that? Well, what we can do is mx plus b. So the b tells us our y-intercept. M is our slope. So because -4 is our y-intercept, it's going to touch the y-axis at -4. Our slope, there's a 1 in front of x. So our slope is 1. If our slope is 1 and we want to use rise over run, it might be good to write it as 1 over 1. Because from here, now we can go up 1 over 1. Up 1 over 1. Up 1 over 1. Draw a dotted line going through it. And there's our slant asymptote. Now, similar thing to what we've done in the previous graphs. We're trying to split it up based off of this vertical asymptote. Let's start to the left. Here it's at -1, so let's go ahead and do at -2. Plug it into our function. Highly recommend using a graphing calculator, as you could tell based on my previous mistakes. Four plus 6, 10, minus 2 would give us 8 over -1. So f of -2 gives us -8. Which means I have to go down lower. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So what this is telling us is here, when we plugged in -2, we got -8 out. So when x is -2, our function's value is at -8. Probably shouldn't have written all this here, but that's okay. And it's kind of bound by this triangular area. And so it kind of does this and then turns there. It goes like this and turns down. So that's what's happening in this section. And we can determine what's happening in this section, maybe plot 0. If we do f of 0, we would get -2 over 1, which means f of 0 is -2. So our function at 0 is -2. So it goes through that point. It's bound by this area, and so it's going to do something like this. And there's our function. So be careful. First, be careful getting your asymptotes. Then be careful plotting your asymptotes. After that, we have to look on each side of our asymptote, plot a point. That tells us what the general shape will be like. If we have 3 sections, which is as most as you'll have on an assessment, we have to do, I highly recommend 1 for the outside sections, 3 points for the inside sections, so we can see exactly what our function looks like. If you have questions, please ask me. I'd be more than happy to answer them.